In this video, we begin our exam review for the upcoming midterm exam in this class. In order to participate, you should log on to SSMS, having started the VPN if you are off campus, and use the Animal Attack database credentials provided on Blackboard. You can find those in the course documents folder. They will not be repeated here for security reasons. The exam will cover and will require you to use the Animal Attack database. Make sure that you study it thoroughly. Make sure that you participate in this video as you follow along. The exam will cover the learning outcomes listed on the syllabus, numbers 1 through 4. There is a 5th learning outcome, and it will be covered after the exam, so it will not be on the exam. Material on the test will come from all of your homework, all the videos that have been provided for you, all the reading that you've done out of the book, and all of the quizzes that you've taken for this class. Make sure that you go back and review the videos, review the notes that you took while watching the videos, practice, redo all the homework exercises that you've already done. Make sure you can do those quickly and efficiently, and make sure that you post any questions about the exam on Blackboard in the frequently asked questions discussion board before the exam. I will answer general questions about the exam if they are posted in the frequently asked questions discussion board. If you ask me a question through email, I will ask you to post it on the discussion board so the answer can be enjoyed by everyone in the class. As we've talked about earlier, here is a suggested template you can use to begin building almost any select query, and certainly any select query that we've written in this class. You can copy and paste this into SSMS, as I have done here. I also added a use statement to tell SSMS which database we were pointing towards. That's not part of the select statement, but it is very useful in SSMS to avoid confusion. The Animal Attack database is a little silly. It's meant to be fun. It's not a serious database that I've used for any customer. I made it up for us to study and talk about. In the database are animals and the attacks they perform. Again, this is meant to be silly. Animals aren't attacking us on a regular basis, I hope. It also includes government agencies that regulate the animals in the database, pet foods that the animals eat, first aid required for the different kinds of attacks that the animals perform, where the animal attacks can be found on television, and the ratings, the severity level of individual attacks. I would strongly encourage you after and during this video to review the database, study it carefully, look at the structure of it, make sure you understand where the relationships are, what the primary and natural and surrogate keys are, so you are well prepared to take the exam. Another document with which you should be very familiar is our naming and design conventions that we've talked about in several videos before this. If you understand how we name things, you will have a much better understanding of how to create the queries, because I have built in semantics that tell you what a field might be based on how it's named and based on the table in which it's contained. These are not rules that you have to follow when you name tables in SQL Server. These are commonly used conventions by many different database designers. I use them for the work that I do for customers in the real world. I find them to be extremely useful because when I come back to look at something a year later or 5 or 10 years later, I have a much better idea of what it's supposed to be doing simply based on the way that I've named things. You will not always see this in the real world. I'm not saying this is the only way to do things. I'm not saying this is the absolute best way to do things, but it does work, and it helps us immensely understand the structure of a database. Take some time to study the tables in the database. For example, let's look at the attack database. You can certainly browse the rows to get some feel for what the data might look like. It's always good to have some semantic information about the database when you start writing queries. You can look at the structure of the database by going to Design View, and when you do this, you will get a warning message that you don't have permission to make changes, but that's okay. You can click through that. This is a simple but common structure that we use for tables. There is a primary key called attack ID, and we know from our naming conventions that if it's the same name as the table and it ends in ID, as this one is, attack ID, then it is the surrogate key. It is configured as an integer, and we know that it is configured as the identity specification, meaning that every record you add will automatically be assigned. Whoops, this one's not, is it? Now it is. Every record you add will be assigned a unique integer value by the database engine. You don't have to worry about that. It's done for you. This is a very, very convenient way to create a surrogate key, and we do it all the time. The other column, attack, should be the natural key. We can look at indexes and keys, and we can see that there is a key that references the column attack. It is set to be unique, and it is set to be an index. Therefore, it is our natural key. And it pretty much has to be because it's the only other column in the table. You should do this for all the tables. You should also look at relationships, because there you can see that this table participates in a relationship with the table called attack channel, and it participates in a relationship with a table called first aid attack, or attack first aid rather. And you can learn then that there are foreign keys in those other tables that refer back to this table. We're seeing then the building blocks of a many-to-many relationship between this table and other tables. And it will be to your heavy advantage to have a good understanding of these foreign keys and these relationships when you come into the exam. This is the same kind of prep you would do at a job to learn about a database before you began to write queries against it. Take some time to study all the tables. What should you be able to do with this database in order to be successful on the exam? Well, there's always terminology in any technology that you study. Some very important terminology in databases are the types of keys. Make sure that you read about those keys in the book, and make sure that you can identify them in all the tables, and you can talk about them and explain what they are and why they're useful. If you can't define these terms and you can't apply these terms, you need to make sure that you can do that before the exam. Another thing you should be able to do is identify the relationships between tables using foreign keys and primary keys. Be sure you can explain what a relationship is, why it's important, how you use it to write a query, and how you would create it when you built tables. We've done all those things in previous videos, and we've done all those things in homeworks. Make sure that you understand the concept of a join. Absolutely crucial. if you were to write effective queries. We've done this in the homeworks. We are primarily concerned with inner joins and outer joins. We are not going to worry about cross joins. We touched on those in a video. We discussed how they're probably not something you're going to do very often. They're not emphasized in this course. The right outer join, the left outer join, and the inner join are what we are primarily concerned about. There is a video that goes into great detail about joins and also the Venn diagrams that illustrate those joins. Make sure that you review that video, take notes, and you can apply what's taught in that video. Another thing you need to be able to do to this database in particular is to use domain language, use the terms that the database tracks, the semantics of the database, to describe what's going on. In other words, you should be able to explain the purpose of, let's say, the pet attack table. And if you look at the columns in the table, you will see that there is an attack ID and a pet ID, and you should be able to explain how those are foreign keys that define relationships between pets and attacks. And since this is an intermediate table, you would be able to explain that there is a many-to-many relationship between pets and attacks. In other words, a pet may attack in many different ways, and a particular kind of attack may be performed by many different pets. A many-to-many relationship. And of course, you need to be able to write queries. I will be giving you English language queries to implement in the exam the same way we did in the homework. You will write those queries, you will provide a screen snip illustrating your results, and you will submit that as part of the exam. For each table, make sure you can apply the terms foreign key, natural key, surrogate key, and foreign key. All the tables have a primary key, a surrogate key, and a natural key. Not all the tables have a foreign key, but if you look at the design standards in the document that I provided, you can see how the naming of these columns indicate what type of key they might be. Not all columns are keys, but in our particular case, we have a very small database with very simple tables, and the keys are pretty easy to pick out because there aren't a lot of other fields in those tables. When you go back and examine the database, make sure that you point out, make sure that you make a list in your notes of all the intermediate tables and the many-to-many relationships those tables implement. That will help you immensely when you're writing the queries on the exam. Let's practice a little, starting from a very simple basis. Let's create this should say query. Let's create a query that gives us all the animals in ascending alphabetical order. This one's very easy. It's just one query. This is from way back at the very beginning of the course. The first thing we need to know then is what table our data is in. We need all the animals. Where are the animals? Well, hopefully from our studies at this point we know where the animals are. And they happen to be in the pet table. We built in a little bit of fuzziness, a little bit of institutional inconsistency, just to get you focused and help you understand that not all databases will be 100% consistent in their naming. The animals are in the pet table. Even though the database is called Animal Attack, we don't have an animal table, we have a pet table. But everything else is pretty much straightforward and named correctly. The question then we were going to answer is all the animals in ascending alphabetical order. We've told SSMS we're using the animal attack database by putting in a use command. Select star from tpet order by pet. If you're not sure, refer to those columns. And the only thing in there that looks like it might be a type of animal is the word pet. If you're really not sure, it's okay. Look at the data. And those appear to be pets. They at least appear to be animals. I don't know if all of those would be officially pets. I probably wouldn't have a fruit fly as a pet, but they are animals, and that's close enough. We can run this, and we get the pet ID, we get the pet, we get the government regulatory agency ID that regulates that pet, but we really don't want all of that information because the query request is all the animals in ascending order, meaning that we should eliminate this star here and just ask for the pets. When we run that, we get pets in ascending alphabetical order, and we can see there are 42 rows. A good sanity check to make sure that this appears to be correct, we should at least make an attempt to see if we did it correctly, is to let SSMS do the same thing for us. Right click on the table, select top 1000 rows. We get 42 rows. Look in the lower right hand corner there. And that gives us some level of confidence that since we got 42 rows and since SSMS SQL Server got 42 rows, we probably wrote a correct query. Okay. That was pretty easy. Let's do an aggregate query on the next slide. How many animals are there? And we are mapping animals to pets. Let's take this out. This is an aggregate query because it is a giveaway. When we see how many, it's probably an aggregate query unless there is a column with a total amount in it, which there almost certainly will not be. We need to count the number of rows in some result set. In this case, the result set is all of the animals, which happens to be just the animals table. We don't have to join any tables. Select count pet ID from tpet. How many animals are there? This will count the number of rows in the pet table to give us the number of animals. 42. We aren't done because we do not have a column name, which is very bad form. Let's provide an alias. Count of pets, perhaps. Your name may differ, but I expect it to be somewhat descriptive and readable and helpful to the user. Run that, and we get 42. That's the same number we got before. When we listed all of the rows in the table, our total rows was 42. Our count is 42. That makes us think that we did this correctly because we got the same number that we got in the previous query when we listed all the rows individually. In this case, we just counted all the rows. A hot tip for you, when you're counting something, it is best to count a key because then you won't have any duplicates and you won't get a misrepresented value. Pet ID is the surrogate key, also the primary key. That's a good thing to count. If we count something that has duplicates, We won't get all the rows because some of the rows will appear twice and they will not show up in the count. Here's another aggregate query. The animal that has attacked the most. Here's our next query. What animal has attacked the most? We need attacks and we need animals. We know where the animals are because we've already looked at the pet table. Where are the attacks? Well, let's look at the attack table because that looks like a possible candidate. In the attack table are simply kinds of attacks. I don't see individual attacks by individual animals. And again, if you just came at this cold, you would be in a bad way. It is in your best interest to prepare by studying this database before the exam. We don't need this. What we actually need is the intermediate table that joins pets and attacks to create individual incidents of attacks. Notice there is a pet ID column and an attack ID column, which by our naming conventions must be foreign keys because they end in ID, and they do not share the name of the table because the table is called pet_attack. One row then represents one attack by one pet on a particular date. So the first row is pet ID 27 committing attack ID 49 on this date, and you can ignore the last two columns. We will not use those. What is pet ID 27? Let's look at the pet table as an exercise. And I don't see 27 in here. Let's add a where clause because I'm not sure that I didn't miss it. I can modify the query that SSMS wrote. And there is no pet ID 27. Okay, so that record is kind of an orphan. It doesn't really have a pet that goes with it. It could be, we could call that corrupted data, we could call that an error, we could call that something that needs to be fixed down the road, but let's just pick one that's a little more illustrative of our situation. What is pet ID 36? Let's go back here and run 36. Again, it's not there. What's pet ID 21? Let's try 21. Pet ID 21 is a weasel. Weasels are attack prone. And it commits attack ID 43. And it committed that attack on that particular date, January, February, March, April 8th, 1932. It was a bad day for weasel attacks. Let's look at the attack table. We're looking for 43. Do you see 43 in here? Let's put a where in. And there is no 43. We're seeing then that our data at this point isn't the greatest because there right away we found 3 rows with orphans. We found 3 rows that don't have corresponding pets or corresponding attacks. And let's try again to find something that fits our purposes a little bit better. Let's look at this record. It is pet ID 20 and attack ID 85. Let's set pet ID to 20 and let's search again. 20 is a tiger and attack ID 85. Still don't find an attack ID. Let's try another record. Let's try 10. We want attack ID 49. Doesn't exist. Instead of going through all these records, I am going to pause the video, and in the magic of science, I will find us a record that actually has a corresponding pet ID and corresponding attack ID. I will be right back. And we're back. Through the magic of time warp, we have found a row in the pet attack table that has a corresponding pet and a corresponding attack. Pet ID 63 and attack ID 20 both exist in the tables that you were given. What is pet ID 63, just out of curiosity? Pet ID 63 is an alpaca. What is attack ID 20? Is a sneeze. That means that in 1973, on October 22nd, an alpaca sneezed on someone, and that was considered an attack, and that was logged in the database. We're just illustrating the fact that this intermediate table contains foreign keys that relate to a particular pet and a particular attack. And this intermediate table allows us to create a many-to-many relationship. The semantics for that are that a pet can have multiple attacks, and an attack, a sneeze, a bite, a lick, can have multiple instances by multiple pets. Many pets, many attacks, many-to-many relationship. This is an aggregate query because we see the keyword most. We need to add something up and then retrieve the row that has the highest value of that sum. Now I am going to create a new query. Specify the animal attack database and paste in the template from the slide that I gave you, and then I'm going to fill in the query clauses that I need and eliminate the rest of the query clauses. I like to start with the from, because that creates the overall result set, and then I can start filtering it, grouping it, sorting it, selecting columns from it. But unless I have the appropriate values in the results set, I can't continue doing anything else, because all of the other clauses refer to things that originated in the results set. Now I'm going to need to know two things here. I'm going to need to know the sum, or the count rather, of all the attacks, and I'm going to need to group that by animal. And then I'm going to take that number that is the highest. So I know that I need pet attack, and I can join that on tpet. And that will give me all the pet names, the names of the animals, and all the times they've attacked. What is the common field between those two tables? Well, if you don't know, you'd have to look. Let me give some aliases. But I can tell you that it is p dot pet ID equals pa dot pet ID. There is a common field between the two tables. Do I need a where clause in this? No, there is no filter that I need to do. Do I need a having clause? No. There is no filter after the grouping operation that I need to do. Do I need an order by? No, because it only wants one animal. Get rid of the order by. But it is an aggregate query. I need to group on something. And as we've talked about before, we probably almost always are going to need to group on a key, because if we don't, we're going to get duplicate rows. So I can group on pet, because that's a natural key in the pet table. And then I can select pet. And I got rid of my order by perhaps too soon. Let's add that back. And I want in here count. Yeah, count. And what do I want to count? I want to count the individual rows that appear in each group and what's going to be unique in each group. How about the primary key in the pet attack table? So PA dot pet attack ID, and that will count the rows in each group. Can I run that? Incorrect syntax nearby. Oh, I left out my order field. And there's the pets and the individual counts for each pet of how many times the pet has attacked in the attack table or attack intermediate table. Still not where I want to be though, because I want to sort in descending order by that, and I didn't even give it a name, so let's put our alias in here. Count of pet attacks. Can't hurt to run it again. And then let's, instead of ordering by pet, let's order by the count. And then let's order by descending. Butterfly. I only want the one that's attacked the most. I want the animal. So, you know what's coming here. Top one. And there's my answer. So the answer to the question, what animal has attacked the most, is the butterfly. And the next question would probably be how many times did they attack, and I can provide that in the query, 1,529 attacks. Then that's a reasonable answer for this particular query. The next query, on what day of the week have the most attacks occurred? Hopefully you realize it is an aggregate query because it has the word most in it. We are going to be counting attacks after we group by the day of the week. And you saw in the study of the database that the pet attack table, the intermediate table, joining pets and attacks, has a date timestamp, which you can use to extract the day of the week. And if you write this and you solve it and send it to me through email, I will give you extra credit. And that is a reward for sitting through this video to this point. I'm not going to say any more about it, but you are welcome to submit a solution for extra credit through email. Make sure you identify yourself, the class you're in, why you're sending me what you're sending me, so I don't get something unexpected, and I will reward you for that. The next query, what pets eat chocolate chip cookies in ascending alpha order? We need to somehow relate pets and food. Well, we know there's a pet table. Is there a food table? From our study of the database, we have realized there is a table called pet food. If we look in there, we see that all it has are pet foods, along with, of course, the surrogate key, which is the primary key. And there are 48 different types of food. How do we relate the pet food table with the pet table because they are not immediately connected. I said the word intermediate because that's what's coming up next. The pet_pet food table is a connection between pets and pet food. Again, the intermediate table implements a many-to-many relationship. One particular pet may eat many kinds of food, and one particular pet food may be eaten by many kinds of pets. A many-to-many relationship, therefore there must be an intermediate table. So the solution to this one is to join the pet table, the intermediate table, and the pet food table into a big query, then filter by chocolate chip cookies, and then list out all the distinct rows. If you skip ahead, I would suggest right now that you try to solve this, turn the video off, and create your own solution before we charge ahead. I will pause briefly. Hopefully you have solved this. You can see that we did an inner join. We want to intersect the two tables. We want the common rows between the two tables. And we're joining on a common field. Pet food and pet ID is in both of the tables, pet and pet food. Sorry, pet_pet food. We don't necessarily need the pet food table because we can use the pet food ID, which is in the intermediate table there, which is a pet food ID of 1. So we could join 3 tables, it'd be perfectly fine, but we'd find out at the end that we only need 2 of those tables. Here's a query that requires you to use a check for a null value in the results set. And when you see this, do not, then you know that there is probably going to be a check for a null. There's probably going to be a situation where there is no corresponding value in the table with the foreign key, and you're going to have to check for a null. What animals do not eat any of the foods? Here's the solution for that one. We join pet food. We join pet and the intermediate table pet_pet food. But, and here's the trick, we did a left outer join saying we want all the records in the pet table regardless of whether they are corresponding values in the pet food intermediate table. But then once we've got that entire result set, we're going to filter and only take the records where there were no corresponding records in their intermediate table. Study this very carefully. We are often asked to find out what things don't exist, or what things don't match up, or what records have no corresponding foreign keys. And this is the way to do it. We use an outer join, and we look for a null value in that foreign key field. I refer you back to the video that I created earlier in the course that explained how to do join types, and you should review that if you're not sure what a left outer join is. Here's another aggregate table. In our database, animals are attacking and TV channels are covering those attacks. We created a table then that tells us what TV channels are interested in what kinds of attacks. Some attacks are boring, they're only covered on certain channels. Some attacks are covered on ESPN. This is silly. It's not meant to be real world, it's just some data for us to work with. The question being asked, what are the channels and the number of attacks each channel covers? And we want that result listed in descending order by number of attacks. You should try to work this out on your own. Think about the order of things you have to do. Create a result set that has the information that you need according to this question. And then filter that result set. And then enter your aggregate values into the select clause. Then you may want to add a having clause. Then you may want to do a sort to get the exact results desired here by this question. And if you look on the next slide, I'll pause for a moment. Hopefully you're writing the query feverishly right now. You paused the video. You're writing the query. Here we go. There's the solution that I came up with. The solution gives you the channel and how many attacks, how many different types of attacks are covered by that channel. Animal Planet is interested in 145 different types of attacks. ESPN is interested in 13 different types of attacks. Not individual attacks, but different types of attacks from the attack table. Again, if you haven't studied the database, a lot of this is going to confuse you, so be sure you have a thorough understanding of what is in those tables and how they relate. Here's another aggregate query. How many pets eat chocolate chip cookies? You may want to go back to the previous query that we wrote in this video and start with that select statement and adapt it to your needs. Here's a solution that I came up with. All I do is grab records from the intermediate table, knowing that pet food ID 1 is chocolate chip cookies. Actually pretty straightforward if you know the structure of the tables and you know how to create a simple aggregate query. Don't forget your alias. I used count of pets, which is a pretty good answer to the question, how many pets eat chocolate chip cookies? The column is titled count of pets. The answer is 7 pets eat chocolate chip cookies. Here's another query. In this one we need a null value because we have the word not in the query. We need to exclude rows that have a matching foreign key and only include the rows that do not have a matching foreign key. What animals don't eat any foods? Hopefully you've seen a pattern by now that if there is a null, it's probably an outer join, because we want rows that are not included in the intersection of the two tables. And there's my solution. I joined the intermediate table pet underscore pet food with the pet table. The common field is pet ID between those two tables. And I got a nice column of pet ID values, which is horrific. You can see the note on the slide. This is not sufficient. And this is not sufficient because these pet IDs have no meaning to anyone except the database designer. So telling you that pet ID 8 doesn't eat any of the foods has no meaning to you. You don't know what pet ID 8 is. Of course, if you were to take the time to go back to the database, open it up, and look for pet ID 8, if you were lucky enough to find it, you would find that it's an elephant. But that's way too much work, and that does not answer this question, what animals don't eat any of the pet foods? Because pet IDs don't have meaning to people. They only have meaning to the computer. So you would have to modify this query to provide more than just the IDs. You would have to modify this to provide the actual semantic names of the animals. I'll leave that up to you as an exercise. Modify this SQL to return the pet name, not just the pet ID. It's a trivial exercise. It's easy enough to do. At this point then, we've been through a review of what we've done so far in the course. We've illustrated what's going to be on the exam in a general form. We've talked about what you should be able to do to the database, and I wish you well on the exam. Next week I will be posting more information about when you will take it and how you will take it. But I expect you to spend this week preparing for the exam by reviewing the videos, reviewing your notes, above all, studying the animal attack database, and above all, writing queries against all of the databases you've been given to this point. I believe you have numerous opportunities to write queries against numerous databases, and you also are welcome to post questions in the FAQ. If you want more help, if you want practice, if you want me to look at something that you did, please feel free to post, and I'll be happy to respond. Good luck.